Hey, fifth grade, how's it going? Welcome to another lesson in math. Today we're going to learn about how to convert improper fractions to mixed numbers and into decimals and whole numbers. We're also going to be able to add mixed numbers, okay? Add fractions to create mixed numbers and later on make them whole numbers. So let's begin. What I'd like to do is just first go to page 52 and finish up those problems. So last time we were working on these two problems, 4 divided by 3 and 11 divided by 4. What I want you to remember, boys and girls, is when we do these types of problems, these problems are basically just division problems, okay? The improper fraction is basically just a division problem. For example, if we have 15 divided by 3, that's another way of saying 15 thirds, or 15 divided by 3. Before, when we were doing division, we would take the dividend divided by the divisor and get our quotient. And sometimes we get a remainder. Now in this case, we're going to have to divide and make sure our answer is a decimal. Okay, so for example, if we have 3/4, that would be 3 divided by 4. In other words, the numerator divided by the denominator. And we would get a decimal form. In other words, if we have an example like 24 divided by 4, we're taking 24, the dividend, dividing it by the divisor, 4, to get our quotient, 6, which in this case is a whole number. But that's not always going to be the case. Let's take a look at letter C and D and do these problems together. Letter C says 14 divided by 6. Well, if I look at my 6 tables, I know that 6 can go into 14 2 times. If I divide that out, I'm going to take 14 divided by 6, and that gives me 2. 14 minus 12 is 2. And like I said before, we were using remainders, but the directions say that we're supposed to be finding our answer as a decimal. So what I'm going to do is I'm going to put a decimal point to the right of our 14, it's our whole number, and put a couple of zeros afterwards. In other words, 14 is the same as 14.0 or 14.00. It's the same exact number. All right, what I'm going to do is right away put my decimal point into my answer. So my answer is going to be 2 point something. You can also use a comma to separate. I'm going to bring my 0 down, and now I'm going to ask how many times does 6 go into 20? Well, 6 times 3 equals 18. So let me just erase this so that I can finish out my division problem. So we have 6 times 3 equals 18. Okay, what I'm going to do now is subtract 20 minus 18, which equals 2. And I'm going to bring my 0 down to my next spot to continue my division. Again, 6 times 3 equals 18. So I put my 3 in my top spot, and 6 times 3 is 18. 20 minus 18 equals 2. This is just going to continue forever and ever. So our answer, boys and girls, is 2.3. Okay? Let me just actually put that right here. I write that with our text tool. 2.33. Okay, it's kind of small. Can't really see that very well. Sorry about that. You can also see the answer right there. All right, let's try the next answer. What I'm going to do is erase everything on the screen so that I have enough space to do letter D. Again, our answer was 2.33 for our first problem on this page, page 52. 2.33. All right. How many times does 8 go into 19? Well, if I count by 8s, 8, 16, oh, that's it, just 2 times. So our answer is going to be 2 point something else. This time I'm actually going to use a point. We use points in the United States to separate out our whole numbers and our parts of our numbers, and we use the comma in Costa Rica and other places. All right, so let's divide this out. We have 19 divided by 8. I already know that 8 goes into 19 two times. 8 times 2 is 16. Subtract 19 minus 16 equals 3. And right away, I am going to put my decimal point in the spot right next to my 19 and add a couple of zeros. I'm going to bring my 0 down. Technically, what I'm doing is asking how many times does 8 go into 3, not 30. So in that case, I'm going to bring my decimal point up to my answer. 2 point something, like I said before, is going to be our answer. And 8 times what number goes into 30? Well, 8 times 3 equals 24. So 3 goes in my spot on the top. 8 times 3 is 24. 30 minus 24 equals 6. All right, I can keep going. I can bring another 0 down. And I'm going to ask how many times does 8 go into 60? Using my trusty multiplication table, I know that that is 7. 7 times 8 is 56. So 60 minus 56 is going to give me 4. I could continue if I wanted to. Would bring another 0 down. Put my 7 in that spot. 8 times 7 is 56. And 8 times 5 would give me 40. And then 40 minus 40 equals 0. So my answer is 2.375. We really only need to put 2 numbers to the right of the decimal point. So let's just leave it at 2.38 if we're going to estimate. Okay? So you have your answers for letter C and D. Hopefully you understand how to do this. This is the same exact type of problem that we've been doing in your Maximo book in Spanish. So make sure you check that out. If we would like to check these, for example, we could check the first problem. Let me show you. If we have 14 divided by 6, our answer is going to be 2.333, repeating. Okay, so we could put a little line right there to show that this 3 is going to be repeating. And if we wanted to check letter D, we could do the same thing. 19 divided by 8 equals 2.375, just like we came up right here. Okay. We could also check it looking at it in a different standpoint. Instead of dividing, we can multiply. So for example, 8 times our answer, 2.375, we get 19, exactly like our first number, right? That would be our, for example, let me just erase all of that, just like our dividend, okay? Good. So what we're going to do, boys and girls, is just take a little break with division of improper fractions, and just remember that it's important to understand the concept of reducing fractions. If you'd like to know a little bit more about this, you can play the game, which is also going to be linked inside of the video notes below. This game is all about reducing fractions. It's from shepherdsoftware.com. What you have to do is you have to look at the fraction. You have to reduce it by dividing both sides by the same number. In other words, in this case, it would be 5. 5 divided by 5 is 1, and 15 divided by 5 is 3. So you'd have to find 1/3 somewhere around here, like right there. You touch it, and then it goes away, and it gives you a new fraction. So check that game out. It's actually kind of fun. We played it in class. Let's go on and here you go. I actually got a really high score, and we got a really high score in class too. Let's go on to adding fractions. Now, before we go on to this, I'd like for you to understand that when you add fractions, it's basically the same thing as just adding the numerators as long as the denominator is the same. Okay? As you can see at the example on the board, 3/4 plus 2/4 equals 5/4. As long as that denominator is the same and it speaks the same language, or in other words, it has the same last name, you can add it very easily. Now, what happens if you don't have the denominator the same? Well, let's look at some examples on page 54. So on page 54, you can see that for the first example, we don't have two fractions with the same denominator. We actually have 7/8, which is 8 as the denominator, and 3/4, which has 4 as the denominator. So what do we need to do with that 3/4 in order to change it to 8ths? Well, simply enough, all we do is multiply. So if we take 3/4 times 2, and we multiply times 2 on the numerator side and the denominator side, we're going to come up with 3 times 2 is 6, and 4 times 2 is 8. So that changed to the same denominator. Now they are both 8ths. Sorry. So before, this was not 8ths, this was 4ths and 8ths. Okay? So now we can easily add these fractions together. Okay? We have 6/8 plus 7/8. Now, just like we did before, the example, since the denominator is the same, so we just add the numerators. 7 plus 6. 7 plus 6 is 13. So, our answer is 13/8. But we're not completely done yet. What we need to do with that number is we need to simplify it even more. Our directions say, find your answer to the simplest form. So if 13/8 isn't the simplest form, what do we need to do to get it to be as simple as possible? Well, let me actually draw a couple of 8ths on the bottom, just so that you understand this. If we separate these pie pieces into 8ths, what we can do is just count how many 8ths we have. Well, we have 13 of them, so let's count. Change the color. We have 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, and 8/8. Okay, 13/8 equals 8/8 plus 9/8, 10/8, 11/8, 12/8, 13/8 plus 5/8. Okay, as you can see, I represented 13/8 on the bottom. This is 1 whole plus 5/8. In other words, our answer is 1 and 5/8. That's your final answer, okay? You can see that each one of those separate parts of the eighths were all represented in 13/8, and then we separated out into the whole and the part. Let's do the next problem, letter B. Let me change the color so we can make sure that we're understanding this a little bit better. Okay, so here we go. In this case, we have 2/3 plus 4/9. Well, 4/9 is just going to stay the same. We don't need to change that one. So what do we need to do to get thirds to change to ninths? Well, we need to multiply by what? 3. So let's multiply both sides by 3, multiply our 2 by 3, and multiply our 3 by 3. In other words, we changed 2 to 6 and 3 to 9. Now we have 6/9 plus 4/9. And all we're going to do is add the numerator. 6 plus 4 equals 10. So our answer is 10/9. However, that's not the simplest form. How do we figure out what 10/9 is in its simplest form? Well, we can break it up into wholes and parts. I know that 10/9 equals 9/9 plus 1/9. 9/9 is equal to 1 whole. So 1 is part of our answer. And the 1/9 plus 1 equals 1 and 1/9. That's your final answer. Boys and girls, make sure you check both answers, which I am currently putting in a green circle. to make sure that these problems are correct. On page 54, letters A and B. All right, let's erase this and go to problem C. Problem C is going to be very similar because we need to add the fractions again. Let's do it. I know that we have fifths and tenths, so I'm going to change fifths to tenths. I can multiply both sides by 2. 5 times 2 and 4 times 2. All right, 4 times 2 is 8. And 5 times 2 is 10. That tenths is already displayed on the screen for you. So what are we going to do with these numbers? We're going to add them. 8 plus 3 equals 11. And the tenths stay the same. We don't change our denominator. In other words, we have 11 tenths as our answer. But that's not our final answer because we still need to simplify. What is 11 tenths as a simple fraction? Well, let's break it up into parts and wholes. I know that 11 tenths is equal to 10 tenths plus 1 tenth. And I know that 10 tenths equals 1 because it's one whole. And 1 plus 1 tenth equals 1 and 1 tenth. So there's your final answer, 1 and 1 tenth. Boys and girls, it's important to understand that each one of these numbers contains wholes if the number on the top is the same as the number on the bottom. For example, 13 thirteenths equals 1. If you break a pizza up into 13 slices and 13 people eat all 13 of those slices, they've eaten one whole pizza. Doesn't matter what number is on the top, as long as it's the same as the number on the bottom, it's always going to equal 1. For example, 365 days lived within 365 days equals 1 year. So 365, oh, oops, did that wrong? 365 over 365 equals 1 whole. Okay, it's always going to be 1 whole. Doesn't matter what number is on the top, as long as it's the same as the number on the bottom. All right, let's do that last problem. The last problem says 3/4 plus 7/12. Again, my denominators are not the same, so let's make them the same. What we need to do is multiply each side of the first fraction by 3. 4 times 3 and 3 times 3. 4 times 3 now is 12ths, and 3 times 3 is 9ths. In other words, 3/4 is exactly the same as 9/12. All right, 7/12 is going to stay the same. That doesn't change. What is 7 plus 9? 16. In other words, our answer is 16/12. But we have a problem. We need to simplify that more. And the next step says that we need to change this to thirds. I wonder why. Well, it's because we can still simplify this fraction even more. If I divide both 16 and 12 by the same number, I can simplify that and make a reciprocal fraction. What number should I divide by? You're right, 4. If I divide 16 by 4, I get 4. And if I divide 12 by 4, I get 3. In other words, we have 4/3 as our answer. However, 4/3 is considered an improper fraction. And since it's improper, it's not considered simple. If I draw out 4/3 right here on the bottom, and I count thirds one by one, I know that 4/3 is equal to, well, 1, 2, 3, 4. We have 1 whole and 1/3. In other words, 1 and 1/3 is your final answer. Check to make sure that your answers are correct. I am putting both of the answers in a black circle. Letter C is 1 and 1/10, and letter D is 1 and 1/3. Boys and girls, thank you very much for attending class. We're going to get to the next couple of problems on page 54 and 55 during the next class. If you would like to play one of these games, fractionforkids.com, this is a great way for you to understand how to add fractions, and especially kind of simplifying them to get whole numbers. So check that out. I will put the link in the video notes below this video, and we will see you during our next class.